All right, let's take a look at the graph of y equals the absolute value of x squared minus 2x subtract 3 divided by x plus 1. All right. And here you can see what we get. We get a really interesting graph. It's got a break in it. And we can see that if we are going from the left-hand side and getting close to -1, we're getting really close to 4. If we're on the right-hand side, you'll notice we're getting really close to +4. Right? And that's because depending on which side of -1 you are on, you have different definitions for the absolute value of x. So we're going to be taking a look at limits that involve absolute value. If you understand how absolute value is defined, then you'll have a much easier time with these limits. Absolute value limits have to be investigated from both the right-hand side and the left-hand side, because often what's going to be happening is that they will have different values on the left and right, because absolute value has two possible representations. Either it's x or it's -x, depending on whether or not you have to switch the sign. Now, I don't really have enough room here, so I'm going to bring in another sheet of paper on which to analyze the absolute value of x squared minus 2x subtract 3. You'll remember this has two possible values. It's either x squared minus 2x subtract 3 or negative x squared subtract 2x subtract 3. And we're interested in when it takes on those values. We do this through sign analysis of x squared minus 2x plus 3. Right? Factoring that, we see that it's x, sorry, a little copying mistake there. It's x subtract 3 times x plus 1, which means that when we put our factors along the side, we have x subtract 3, x plus 1. We draw our number line along the bottom. -1 and +3 go onto our number line because -1 makes x plus 1 0, and +3 makes x minus 3 0. Do our sign analysis and find our results. And we notice that x squared minus 2x minus 3 is positive from -infinity up to -1, and also from 3 to infinity. And it is negative between -1 and 3. Now we are really interested at this point right here. And what that means is that on the left-hand side, we don't have to do anything to our absolute value sign, but on the right-hand side, we have to take the negative. So let's see how that translates into our limit analysis. So approaching from the positive side, we see that we have the limit as x approaches -1 from the right-hand side. The absolute value of x squared minus 2x minus 3 on the right-hand side is negative x squared minus 2x subtract 3 over x plus 1. We can factor the top. Into x subtract 3 and x plus 1 all over x plus 1. The x plus 1 is a common factor, and you can cancel common factors. And we can now plug in the value of -1. So we get -1, subtract 3, which is -4, which is equal to 4. That's our limit from the right-hand side. Now we'll look at it from the left-hand side of 1. You'll remember from our analysis that on the left-hand side, x squared minus 2x minus 3 is positive, so we're going to be using the top definition. So this is the limit as x approaches -1 from the left. So this is just going to be x squared minus 2x subtract 3 divided by x plus 1. We can now factor the numerator to x minus 3 and x plus 1 over x plus 1. The common factors cancel, and we can plug in -1 subtract 3 and just get -4. Notice the limit from the left and the limit from the right are different values. What this means is that there is a jump in the graph. Because the two limits from the left and from the right are different, that means the overall limit does not exist. So let's take a look at what we did here. Right, we figured out the appropriate equation for the absolute value of x squared minus 2x minus 3. Right, that required us doing a little bit of sign analysis work. We chose the proper expression, and then we used the tools that we had at our disposal.